Conductor resistance. All conductors have resistance, with some having more or less than others. There are four main factors that determine resistance. 1. Conductor length. 2. Conductor material type. 3. Conductor temperature. 4. Conductor cross-sectional area CSA. Null. 1. Conductor length. Conductor length is directly proportional to resistance. So, when you double the length, the resistance doubles. Quadruple the length, the resistance quadruples. Halve the length, the resistance halves. In telecommunications, the effect of a very long connecting lead or cable increases the amount of electrical energy lost in a conductor, for example resistance. This can also be called attenuation and is a natural loss of signal in cables. In telecommunications, it is very important to have good electrical connections that also limits attenuation. 2. Conductor material type. The atomic structure of the material determines the number of free electrons that are available. The conductors having a greater number of free outer electrons provide a less restricted path for the current to flow and therefore provide lower resistance. Comparison of conductor resistance. (3) Temperature. The table below illustrates the temp coefficient at 20 for a range of conductors. Temperature for most materials resistance will increase with temperature. Exceptions to this are semiconductors. (4) Cross-sectional area CSA millimeter square. Resistance increases as cross-sectional area square millimeters decreases. Therefore, the resistance is inversely proportional to the CSA. Doubling the CSA halves the resistance and vice versa. The telecommunications industry uses wire diameter, not CSA. Doubling the wire diameter reduces resistance to 1/4. Having the wire diameter quadruples the resistance. Resistance describes opposition to the flow of current in direct current DC circuits. Impedance is like resistance. Impedance can also be used to describe reactances, which are generally as a result of cables carrying alternating current AC circuits. The reactances when using a twisted pair cable is greater than the reactances found when using coaxial cable. This is shown by the velocity of propagation VOP of coax being around 80% and twisted pair being 65%. 100% equals the speed of light. Both DC resistance and AC's impedance are measured in ohms.